we'll see different recombination process are there. We'll see what are the recombination process. Okay. So there is a two recombination process. One is radiative recombination process. Another is non-radiative recombination process. Okay. Radiative and non-radiative. Radiative. Okay. So here what is happening? The electrons, okay, whatever electrons, they directly jump from conduction band to valence band. They directly come to the conduction band to valence band. They will emit some light here. Okay, they will emit a light here. Okay, whatever emitting light is radiative. These are emitting light. That's why it is a radiative recombination process. In this process here, what is happening? So here also there is a recombination, but it is not a direct recombination. Here first one is direct recombination. Direct recombination. Okay, you can write down this completely. In the second process, non-radiative, first here suppose you have a free electron in the conduction band. This electron not directly jumping into the valence band. Okay, these are not jumping into the directly into the valence band. But what is happening here? There is a some defect states in a semiconductor. We know there is no 100% perfect material in the universe, right? There is a slightly some defects will be exist in every material. There is a defects will exist every material. So here what is happening? This electron first they will jump into the trap state. Okay, they will jump into the trap state. Okay, after that if there is a nothing is there, that means holes is there. Here they will recombine. Suppose here hole is there, nothing is there means some hole is there, right? So this electron will recombine with holes in a trap state. Or you can say another way, suppose here a some electron is there in trap state or defect state. Trap or defect, whatever you can say, trap or defect states or defect centers. You can say defect states or centers, because we know every material is there is a some defects, some faults are there. So here also, suppose here in the defect state or trap state, there is a some electron, free electron is there. So this electron will jump into the valence band. Here recombine with holes. It will recombine with holes. So in this process, light will be not emitted. Light will be not emitted. Here phonon will be emitted. Okay, phonon. Okay. So what is this phonon? We'll see. Okay, what is this phonon? We'll see. So this is the indirect recombination process. Indirect recombination process. So if light is emits or photon is emits, here photon you can write photon also. In radiative, electrons jump from conduction band to valence band directly. So it will emit a light or photon. Okay. In non-radiative recombination process, electron directly not jumping into the valence band, and it is not a direct recombination process. Suppose this recombination process happens via trap states or density defect density states or defect centers or trap centers, whatever you can say, it's not a problem. Okay, electron jumps into the trap state or trap center or defect center, and there it will recombine. Or if you suppose a trap center 1, okay, in trap center 1 or defect center 1, free hole is there. So electron jumps into this trap state and recombine with holes. So it will produce a phonon. Otherwise, in other case, second case, take two process 2. In process 2, in trap center we have a electron, free electron. This electron, this will come into the ground state. Okay, and it will recombine with holes. Here, this is also not coming from the conduction band. It is coming, this electron coming from the via trap states. Okay, then here also not photon is not emitting, only phonon is emitting. So we'll see what is the phonon. So why your phonon is emitting means, suppose you are giving some energy to here whatever bound electrons. After breaking the bonds, so here you have it some defect states in a center of the band gap or center of the material. So after breaking the bond, they will enter into this trap state and remains here as a in the trap state only. So here electrons are some of the electrons are not reaching to the conduction band. That's why these electrons stucking in a trap state, or you can say whatever some holes are stucking in a this trap state. Because of these traps, because of these defects, we are not getting photons in this process, only phonons emitting. Okay, phonon means here, okay, what is phonon? Photon means we know light wave. Okay, this is a light. Photon means light. Here it is a some mechanical wave. It is also some wave or mechanical wave. It will, how, when it will produce means, okay, when this mechanical wave produce or phonon will produce means, when electron interact with lattice. Okay, when electron interact with lattice, phonon will produce. Okay, this is the phonon. Phonon means when electrons is interact with lattice, or in a matter it will interact with a some atoms in a lattice. Okay, then it will produce a phonon or some mechanical wave, or it is phonon means nothing but a heat. Okay, you can also say this is a heat. Okay, heat energy. This is interact with lattice and phonon. Okay, this is indirect process and indirect recombination process. This is called non-radiative because here photon is not emitting, phonon is emitting, right? So in radiative, photon is emitting when electrons recombine with holes. Okay, this is the here photon is emitting. So examples are, for a direct, if you take direct band gas semiconductor, mostly compound semiconductor, gallium arsenide or gallium phosphide or gallium arsenide phosphide. Okay, these are the some examples for radiative recombination process. Okay, so in non-radiative means here examples, some examples are silicon and germanium. These are the indirect or non-radiative recombination process. Okay, these are the two different kind of recombination process takes place in a semiconductors. Okay, one is radiative, one is non-radiative. Okay, is it clear to you this process, two process?
Yes, sir.
Direct means,
Sir,
direct,
one second.
radiative means, yeah, okay, okay.
Non-radiatives.
So here okay, so now radiative means, suppose we are giving some energy to this semiconductor, thermal energy or light energy, they are creating holes and jumping into the conduction band. This is the generation process. So second one is after some certain lifetime, these electrons jump into the conduction band and electron hole will recombine. Electron hole will be recombined. This is the direct recombination process. Okay, non-radiative recombination process. Suppose we know there is no 100% perfect crystals. There is no 100% perfect crystal. In that case, what happening? Suppose there is a defect here. Okay, there is a defect center here. If you give some energy, okay, to these electrons, after breaking the bond, they will leave hole in the valence band, and we know another free electrons are creating. They will jump into the conduction band. But here, what is happening? That electron is trapping in a defect center, trapping in a defect center. Okay, that means what? We are creating free hole and free electron, but this free electron is not in the conduction band. This free electron is stayed or stuck in a defect center or trap center, or you can say electrons are trapping in defect center. Okay, or holes are trapping in defect center. Okay, that is what. Suppose here some free electron is there. While recombining, this will not coming into the valence band. Okay, this is coming into the trap state. Here already nothing is there means some hole is there, right? Nothing is there means hole is there. This electron will recombine with this hole. That's why here recombination process takes place via trap centers. Via trap center. Recombination. Okay, recombination takes place. Takes place. Okay, via trap centers. Or trap centers are defect centers. Defect centers. So in this process, electrons are not jumping from conduction band to valence band. Here, what is happening? here conduction band and valence band. These electrons are not coming into the valence band. This process is not taking place. That's why simple as electrons are not directly jumping into the valence band, not directly recombining with holes. They are recombination taking place through defect states or defect centers or trap centers, whatever you can say. Electrons who are trapping, trapping, trapping in defect centers. Okay, this is the process of recombination, indirect recombination. That's why it's not direct. So in this process, what is happening? So when electron recombined, lattice involvement is there. Lattice involvement is there. So because of this lattice involvement, here photon is not emitting. Photon is not emitting. Only phonon is emitting. Phonon is a mechanical wave. It's not a light wave. Just like a heat is a heat. Okay, heat energy. But how this phonon is emitting? So if you take direct recombination process, how the photon is emitting? Just tell me. After certain lifetime, that is directly coming to the conduction band, valence band, and recombining. Why it is emitting photon? Just tell me. I am saying once electron hole recombining, photon is emitting. But how that photon? Just tell me, anyone. Hmm?
Thermal energy.
Yes. What is happening actually? We are giving some thermal energy, and a hole is creating in the valence band, and free electron is creating in the conduction band. After certain lifetime or that their lifetime, they are coming to the ground state and recombining with holes. So I am saying in this recombination process, photon is emitting. But how this photon is emitting? So here thing is, when electron recombine with holes, they lose energy. Okay, they lose, electron is losing energy in the form of photon. In the form of photon. The whatever once the electron recombine with holes, excess energy releasing in the form of photon. This is loss of energy only. So you also know when you have energy, you will climb the ground state energy. Then once you combine this one, some energy will release, excess energy will release. Here also same process. So when electron loss energy in the energy, that loss energy is a photon or some energy. Electron photon is nothing but loss of energy of electron. Okay, electron losing some energy that is releasing in the form of photon. That is why we are saying when electron hole recombined energy. Okay, anyway, tomorrow we'll discuss direct bandgap semiconductor and indirect combination semiconductor. Okay, we'll discuss that thing. Okay, we'll slowly learn this basics and we'll go to the devices. Okay.